In these problems, we will be using the quadratic formula to solve for a value of x. Notice right here it says we have a rectangle is 7 inches long and 3 inches wide. So I'm going to go ahead and draw a rectangle that is 7 inches long and 3 inches wide. Now it says when each dimension is increased by x, the area is doubled. So what's going to happen here to find the area of this original rectangle, you got to do the length times the width. So the 7 times 3 is 21, so the area of this one is 21 inches squared. Now it says if each dimension is increased by x. So what that means is each dimension is going to be increased by x. So our new rectangle, this 7 over here, is going to be increased by x. And the same thing here, this 3 over here is going to be increased by x. Okay. Now it says the area is doubled, so that means the area of this one is 21. I'm going to double that. The area of this one is 42. Now the last part here, it says find the value of x. So what we're going to do is we're going to use this rectangle to find the value of x. Remember that the area of a rectangle is length times width. So what I'm going to do is I'm going to take the length of this times the width of it. Okay, the length times the width equals the area. Well, we know the area of this one is 42 because it was doubled. Okay. Now we just need to solve this equation for x. So what we're going to do now is we're going to multiply these two by using the FOIL method. So I would multiply there and there, there and there. If I FOIL that and multiply it out, I would get x squared plus 10x plus 21. That equals 42. Now, this is going to turn into a quadratic equation. Okay, it already is a quadratic equation. So I want to make one side 0 so I can use the quadratic formula. So I'm going to subtract 42. Subtract 42. And I'm left with x squared plus 10x minus 21 equals 0. So here's my quadratic equation that I'm going to use. I cannot factor that. So my other option is to use the quadratic formula on it. So what I'm going to do is, okay, remember a is what's in front of the x squared. If there's nothing there, remember there's a 1. B is what's in front of the x, so it's a 10. And then I have c, okay, is your constant, and that's right here, negative 21. Okay. I want to solve for x, so I'm going to choose to use the quadratic formula. So I'm going to go ahead and use it. So I get x equals, then I have negative b. b is 10. Plus or minus the square root of b squared minus 4 times a times c. Okay, so I'm going to put in a is 1. And c is negative 21. All right, and then that is all going to be over 2a. And a is 1 for us. All right, now I'm going to go ahead and simplify this. So I get x equals negative 10 plus or minus the square root of 10 squared is 100. And then I'm going to multiply all three of these together. When I multiply all three of these together, I get 84. That's all over 2. Okay. The inside of this is really worth 184, so I get the square root of 184. And since I'm trying to find the exact value of x, I'm going to go ahead and change that square root of 184 into its rounded value of 13.6. Now, I'm going to go ahead and simplify this down. So I'm going to get x equals negative 10 plus or minus 13.6 all over 2. And remember, that'll give you two values, negative 10 plus the 13.6 all over 2. And it would also give you the negative 10 minus 13.6 all over 2. If I find those two values, the first value is going to give me 1.8. Okay, and the second value is going to give me negative 11.8. Now, remember, our goal was to find the value of x. So it's going to end up being, if you come up here, x. Okay, x stands for an increased value here. Okay, so to increase something, it's going to have to be a positive number. So what's going to happen is down here, this negative 11.8 is not going to be a possible answer, because if I would add that in for x, I would get a negative value for the length of the side of a rectangle, so that wouldn't work. So my final answer here is going to be x equals 1.8. This problem is going to be set up very similar to the first one. It says a rectangular garden with an area of 50 feet squared is along one side of a shed. So what that told us right here is this is the garden, okay, and it has an area of 50 square feet, and this is the shed. Now, it says the other three sides are enclosed by 25 feet of fencing. So what that means for us is this fencing, which is going to be this dashed line, is made up of 25 feet, okay, of fence. That's where this 25 comes from. So they've already done the work for you. They said you don't know this side, you don't know this side, but this final side right here is the 25 minus those two x's. They want us to find the dimension of the pin. So what we want to find here is we want to figure out how far it is from here to here, and how far it is from there to there. Okay. Like I said before, this is going to be set up very similar. This right here is a rectangle. So to find the area of that, I have to just do length times width. So I'm going to do the 25 minus 2x times the x. And that will find the area of this rectangle. Now we already know the area of that rectangle is 50, so I can say the area equals 50. Now we just need to set up another quadratic equation so we can use the quadratic formula here. So what I'm going to do here is I'm going to distribute, and I get 25x minus 2x squared equals 50. Okay, and remember, to find the dimensions of the fence, I'm going to have to figure out x and substitute it there, and figure out x and substitute it in there. So what I need to do is I need to set this equation up so there is a 0 on one side. So I'm going to go ahead and subtract 50. I'm going to subtract 50. These cancel to 0. So I'm left with 0 equals. Now over here I'm going to put this in order. So I'm going to have negative 2x squared plus 25x minus 50. And that equals 0. So I need to solve for x, so I can substitute it in here and here. Alright, so I can solve for x. I'm going to use the quadratic formula. So notice this is a, this is b, and this is c. I'm going to write that off to the side. A is negative 2, b is 25, and c is negative 50. So I need to go ahead and plug those numbers into the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c. A is going to be a negative 2 and c is going to be a negative 50. And that's all going to be over 2 times a. Now let's go ahead and simplify the quadratic formula here. So on the next step, I'm going to say x equals negative 25 plus or minus the square root of 625. Now I multiply these three together and I get a negative 400. And then that's all over negative 4. Now we need to keep simplifying this. So above here we'll simplify the radical. So I get the square root of 225. And the square root of 225 is 15. So I come up here with x equals negative 25 plus or minus 15 all over negative 4. But once again, remember this is two answers. I have negative 25 minus 15 all over negative 4. And I have negative 25 plus 15 all over negative 4. Now on this, when I go ahead and divide this, this would be a negative 40 over 4 is going to give me a positive 10. And then down here, this is going to give me a negative 10 all over negative 4. Okay, which if you go ahead and divide that out, you would get 2.5. So those are my two possible answers for x are 10 and 2.5. Okay, so here's what I need to do is I need to keep in mind that my answers here are 10 and 2.5. So I'm going to come up here and write that x equals 10 or 2.5. But once again it said to find the dimensions of the pen. So what I need to do here is I need to find the dimensions of the pen. So what I need to do is I need to substitute this 10 in for this x, and I also need to substitute the 2.5 in for the x. So let's go ahead and do the substitution here. So I'm going to put an x in for that 10, so it would be 10 feet by. Now what I'm going to do is I'm going to substitute a 10 in for that x. So I would have 25 minus 2 times 10, which would be 25 minus 20, which is 5. So one possible answer is 10 feet by 5 feet. Alright, the other possible answer is I can substitute the 2.5 in for the x here. So obviously when I substitute it in for that x, I would get 2.5 by, now I'm going to substitute it in there, so 25 minus 2 times 2.5 is 25 minus 5, which is 20. So it could also be 2.5 feet by 20 feet. So now the question is answer, find the dimensions of the pen. I have two possible answers. The pen could be 10 feet by 5 feet, or it could be 2.5 feet by 20 feet.